Oh, hello, we've already got somebody in. We're just started early to let people in. We'll start on the hour. Oh, and lots of people coming in straight away. Excellent. Yeah, so we'll just hold here. Hopefully, what's up on screen is showing the workshop that you're expecting. It's the ML Agents, Unity ML Agents workshop with me, Ben Clark, hosting. I'll be taking you through that. But yeah, we'll start on the hour, but we'll just let people in. Yep, still just waiting for the top of the hour for people who have joined since I last talked. Yep, this is the Unity ML Agents workshop, which yep, hosted by me, Ben Clark, member of the developer advocacy team in ARM's client division, reaching out to developers to offer best practices and advice and get to understand developers' needs. Client division is aiming at developers who are coding for anything consumer oriented, so anything with a screen. So yep, cover lots of graphics and gaming and ML use cases as well. So this covers pretty much all that with the Unity ML Agents workshop. Just another minute, we'll get started. And we're just on the hour now, so I will get started there. We'll see if more people join just after we get there, but because I've got a first page there for the checklist to make sure that gone through everything in advance. This is if you want to follow along and go through the opportunity to get the scene running on an Android phone. To do so, you really need to have already got all that the background stuff set up. There was a pre-work document on the page. And so if you are going to follow along rather than just listen along, hopefully you have Unity 2021.3.11.f1 installed and have downloaded the appropriate level Dev Summit 2022, and have the scene loaded within that. That's this one here, Dev Summit scenes, assets Dev Summit scenes, the left one there, level Dev Summit 22 within it. Have that loaded up, and it looks something like this, quite similar to this. Yeah, there was a recommendation to check the package manager. I've not seen that go wrong, but it's always nice to check that the right packages are in fact installed there. Also in the pre-work document, the PyTorch and ML agents Python package will all have been installed, and added Android SDK and NDK to your Unity install. And indeed, you'll have an Android phone plugged into your computer that has developer mode enabled and has USB debugging allowed on it. So if that's all good and the setup's all good, there's no questions coming in about setup, so that's good. So hopefully people are either listening along or they are set up correctly. So we should be able to get into it if everyone is set up. Once again, I'll just introduce myself again for those who have just joined. I'm Ben Clark. I'm taking you through the workshop. I'm from ARM's client division and the developer advocacy team within that. Developer advocacy talks to developers. We put out best practices and try and get feedback to how people are using things that interface with developers. And yeah, client is all sort of consumer devices, anything with a screen. So mobiles and DTVs and mixed reality and all sorts. Anyway, right, I'll get into it. So this is what you would need to do if you started from scratch. The background work and the scene have done this for you already. But if you're starting a scene from scratch, starting a project from scratch, you would need to go to the ML Agents GitHub. It's nice and easily found on GitHub. It's Unity Technologies ML Agents. And there's lots of good instructions and tutorials to help you integrate that with your code. But for us, you've done this already. You've installed it in the pre-work, you've installed the Python package and PyTorch. The scene already includes the Unity package, so you've already got that as well. And the scene, in fact, includes scripts that are either directly from the ML Agents repository or inherit from it. We've adapted further. So you've already got that all done, so we can just skip straight over that. And then we can start looking at the actual scene, which looks a bit like this. And I will just go over to Unity now. So there's Unity, and it indeed looks quite like that. So I'm going to quickly just go through the scene. It's a simple scene, but there's still too much to look at everything, and most of it's not so exciting. So we'll just quickly go through the rest of it, and then we'll get onto the agent settings, which is the bit that we'll be focusing on. So the UI is a bunch of canvases to menus and on-screen controls and the like. And the environment here is the mesh and a light. So the mesh is the room and the light. ML Core is a bunch of managers. So there's an event system, the input controller, the particles, and then an app manager for a bunch of other little things, an annotation service here. But if you're profiling with ARM Mobile Studio Streamline, provide much more interesting information through for your profiling. We're not going to get to use Streamline today. We'll do a bit of Unity profiling, but we won't get to Streamline. Yeah, as I say, most of what we're interested in today is the ML agent stuff, which is in the agent settings. So agent settings itself has this battle environment controller script, which we'll look at closer shortly, and a camera, and the two characters that are going to be fighting each other. I'll look through these scripts very shortly, but beneath that, so we've got the player character and the enemy character. They're both set up with ML, because in the demo mode and in training, the player also needs to have ML. But looking at the NPC one, beneath it, we've got the model, the actual skeleton and so forth, and the skinning. The abilities, you can fire some fireballs. It's one of the things you can do, and you need to lock a target on for that fireball. So there's that sort of stuff underneath it, but mostly we're interested in this one here and the scripts there themselves. So I'll just go on to the script thing. Yep, so these are the actions that you can do. You can move about, your joystick movement, and then you've got sword attack, a fireball attack. They're just getting ready to fire it there. It's very hard to capture it mid-fireball. And a rolling dodge, so you can roll in any direction to dodge things. So those are your movements that you can do. But back in Unity, looking at these scripts for the setup, first of all, there's a bunch of general player stuff, third-person movement, the player inventory with your weapons and your weapon slots and your stats for how much health you've got and stamina you've got and ability to fire fireballs, character controller and the lock-on for the targeting and the damage handler and the nav mesh. And then we get on to the ML stuff that we're interested in. So this player manager is a lot of background setup and ability to talk to all the bits that you need to talk to. So it's, yeah, just framework. Decision requester is an ML agent's script itself. Important one, this decision period is how often the neural network in the ML agents actually runs. So this is every 5th frame, it'll run the neural network. It doesn't run every frame. Every 5th frame is plenty. It runs on the physics frame. So in Unity, you have your rendering frames and your physics frames, 2 separate calls. This runs on the physics fixed update rather than the renderer's update. And so every 5th physics frame, it'll run the neural network and make a decision about what it's going to do. And then we tick this that it's going to keep, between decisions, it's going to keep trying to actually do that. So it's not just going to do something every 5th frame. Beneath this is another important script we'll look at deeper soon. It hasn't got too many interesting controls here, but it's got lots of stuff beneath the surface. But whether it's a player or not is here. This behavior parameters is quite important script for its options here. This behavior name is very important for the training when we get to that shortly. The observations are important for reinforcement learning. We can using reinforcement learning as this. So the observations is getting to know your environment state, and the stacked vectors is taking it for a number of frames worth, so that we have some history there. Inference device here is default, which is burst. For ML agents, found very much that keeping it on CPU is where we want to be. So the GPU is technically faster doing it, but you spend more time getting it to and from the GPU than you save. So it's definitely worth keeping it on the CPU. Not much difference between burst and CPU, but for Unity, all things burst is generally the way forward. Well, I see questions come in. There will be a couple of really good places to ask questions, or well, for me to answer questions in the middle, because it would be a couple of deploying things that take some time. So yeah, feel free to get those questions in, definitely. The agenda, we're just going to run through the setup and then just do a few changes to the setup, and yeah, get it running. So it'll progress sensibly. We don't have a so yeah, we'll do some training and then we'll deploy. So cool. beneath the behavior stuff, so at the moment there's a few errors on the behavior because we're going to make some changes. So at the moment it's saying these things aren't quite right. Once we've made the changes, these warnings will go away, because yeah, those bits will get filled in that it's complaining about, and then there's an input controller as well. So after the scripts, we'll do some setup. So we're going to add this into it. Yep, as I just said, the scene's not all set up to run, and it's a workshop, and we want to do some work. So for those of you who have done the pre-setup and want to follow along, let's add this ray perception sensor 3D. Now there's a bit of a cheat here. I'm going to do it the slow way first, and then I'm going to do it the fast way. So you can follow me for the slow way, or you can quickly do the instant way at the end. Actually, if I just quickly switch to the player, you'll notice all these rays shooting out of the player because this one's got it set up, as opposed to the NPC. So that's what we're going to add in. We're going to want to perceive our environment. A very important part of reinforcement learning is knowing what's going on. So we're going to send out a bunch of rays to detect our environment. So we add component, and then if you type ray in, it rapidly filters down to the ones that we want. So ray perception sensor 3D is the one we're adding. And then we're going to make it like the picture I just showed you. First of all, we're going to rename it to the NPC ray perception sensor so that we can find it. And then we have a couple of tags that we want to sense. So the first thing that we want to sense is the player. We need to know where the player is if we're going to attack them. So that's kind of the most important thing. Also, we're looking for the player with our sensors. And the second thing is just called collide. It's looking for walls or anything in the way, any collision mesh, so that we know to avoid it, to move around it. It's quite important. So at the moment, you can see the rays are largely forward. We can't even see sideways, let alone backwards. So we're going to miss a lot of the world, which you might want depending on your game. In our case, we would just want to see the whole world and react to it. So to be able to see even backwards, I'm going to put 180 degrees there, so we can see backwards, forwards, and not much in between, because now those rays have spread out so far, you could easily miss somebody in between the rays. So we're going to pump this up quite a lot. I'm going to put that right up to 20 rays per direction. Very hard to avoid us now. We're going to see you. But the ends of the rays is just here, but we want to see the whole room. So we're going to bump up the ray length as well. Put that to 30. So we can see the whole room, see everything in the room. Unless you're in one of the little nooks and crannies, we will see you. So then we have just a couple more things to set here. So we have stacked raycasts of 3, so it's the last 3 frames, and that suddenly made that warning go away up there. Last 3 frames. So if we miss you on one frame, we will catch you the next frame, basically. We'll definitely find you and know where you are. If we're lucky, we'll have a couple of things so we can tell which direction you're moving in. So yeah, this should be a good extra amount of information to know what's going on in our scene. Now, the other thing is that we're actually missing this wall, which is a bit weird, because the rays are firing out from under our feet, and they're going between the wall and the floor, which is not ideal. Somehow we're hitting this player just by sheer luck. But if we go up to our midriffs, go a meter up, and just fire straight out from there, then we hit everything as expected. So that's that setup there. That means that we now see all our scene, which is what we want. Now, as I said, there was a cheat way. So I'm actually now going to remove that component, delete it again, because there's actually a prefab underneath this. So I've actually removed this component. And so if I revert that, it magically comes back in with all the settings. So yeah, that was just under here for the removed component, and then revert, and it all comes in. So yep, we've got that in. So let's save our scene with that done. So it's our scene is now set up. but we've got some script work that we want to do. So let's have a look through those couple of scripts that I said that we were going to have a look through. So, yep. Now, Unity's got a good integration with Visual Studio. So 2019, whether it's Community Edition or Professional or whichever edition, not 2022 yet, but I'm sure it's coming. So if I go click on the three dots and go edit script on this agent.arm script, it takes me straight into Visual Studio. And this is the agent.arm script. And we have a quick look through this. So there's lots of setup in the start and stuff, working out whose fireballs are whose and that sort of thing. Setting up a little time thing that we're going to use a little bit later. But collect observations is really where we're wanting to be, getting those observations in so the reinforcement learning can make good decisions and get to know what the state is around it. So once again, a few things working out whether there is fire and which direction it is and whose it is. But here's our first bit that we're going to do. We're going to uncomment this out because this is so that we know our current health, our current stamina. So we can hit them with a sword a few times or swing our sword about a few times, then we get a bit tired, we need to take a breath and our stamina comes back up. And then the mana is our ability to fire fireballs. Have we got any ability to fire fireballs left? So these are quite important things to know about ourselves, and also important to know about our enemy. So actually we'll copy those three lines, hit copy. Other things we know about ourselves is whether we're rolling, interacting is using our sword, and then whether we're throwing the fire and where that fire is. But then, yes, we need to know all those things about our enemy as well as ourselves, so that we can know whether the enemy's firing at us and where they are, to how healthy they are and what we want to do. So I'm going to paste that back in here, and then we need to change it to enemy manager so that we know about the enemy's stats, the enemy's health, and the enemy's stamina, and the enemy's mana, ability to fire fireballs. So that's those things there. We also, as a little bonus on the enemy, is the enemy facing us? So I've done a little calculation to work out whether it's facing us or facing away. Good if we can attack from behind, and also they can't attack us. So it's a good thing to know. And that's our 19 observations that we had in our behavior before. So we now have them all in, coming from the script. And yep, so the next thing, so the other side of reinforcement learning, knowing the state, but is also getting a reward. So for our actions, knowing whether our actions were successful and we did what we wanted to do, so we can learn to do the right thing. Now the basic reinforcement learning reward is actually what we've got here. You get 1 for winning, -1 for losing, and then you get minus a very small amount every frame or every small amount of time to encourage you to win fast. So you only get the full 1 if you win fast. So yeah, if you can win as fast as possible, you get the greatest reward, encourage you to do the actions that you want to do. So we're going to uncomment a large chunk of that there, and we just had add reward minus existential. So existential is that number we were working out before, basically based off our maximum number of frames that we want the match to last. We just go slowly more negative, so less reward overall should you win. So yep, that's now got that add reward there. This is being done on the action received. So every 5th frame, when we get the action from the machine learning, so from the neural network, we get the action buffers. So the output of the neural network is possible actions, which match up to exactly what, as we'll see just down here a bit, match up to joystick movement and the 3 things that we can do. So they're exactly the same as the player does. All works exactly the same as the player. You can see stuff about, you can make the same movements, and you can do the same attacks or dodges. So it's got, yeah, the joystick movements or one of the three actions, either attack or roll or fire. It just quickly checks this. So these actions come in, we change our reward, and then it goes through and it checks, am I not a player? If I am the agent, enemy agent, then do this, or if it's in demo mode, do this as well, because the player is controlled by ML in demo mode. So then, yes, it'll do the actions that the neural network requests. And just down the bottom here, we've got the win and lose. So if we win, we get 1. If we lose, we'd want to just set it to -1. The set reward didn't seem to be working. So we've got a wee thing there to cancel out the adjustment that we're doing, the small adjustments, how much they've added up, so that you end up getting -1. It doesn't matter how fast you lose, you've lost. You always get -1. So that's that. I'll hit save on that one. And then if we go back to Unity, it'll have to quickly reload the scripts. And never quite sure how long Unity will take on these sort of things. We'll go back to the other script we want to look at, which is the battle environment controller under the agent settings. If this takes too long, I want to go to that one. There we go. And then we can go edit scripts on this one. So this is the battle environment controller in the agent settings. We edit that script. And start at the top of it rather than the bottom of it. And so, yeah, similarly, this has a bunch of setup, whether we're in hard, what level of fighting we're doing, hard, easy, or normal, or in demo mode, or paused for that matter. So we know what we want, which brain we want to use to make our decisions. We're switching brains depending on how hard it is. So similar setup, working out whether which fire is coming from where. See, this is on the fixed update, and the fixed update of this one is largely checking if for end conditions, has the battle over. So mainly has someone died? That's a good indicator that the battle's over. And then we give the appropriate win or loss, depending on which one died. We activate those, give the reward the right way. And if we're doing training, we put out a nice wee message as well, just so that we can keep track. Also, if we're doing training, we check if it's taken too long. You can take ages in the real battle, but in the training, we don't want them both just standing around forever. So after a certain amount of time, we decide that they both lose. No winners, all losers, and start again and give them another chance to do better. And maybe, yep, actually have a winner. Regardless of how we've lost, we reset the scene, ready for the next set of training. And that reset of the scene, if I come back to that in a second, that reset of the scene, we put the start position just slightly off in training. You don't always start from exactly the same place. We don't want to learn to attack a particular position. We want to learn to attack the enemy. So to stop any weird kind of start conditions or anything like that, we shuffle the player a little, or the player and the enemy a little bit, so they start from slightly different places. But to avoid that, this was the configure agent that I missed up here. So on the update, this is being called each frame, but will very rarely happen. It's really just kind of start and stop and pause that we're detecting here. So if the mode has been set to something different, then we need to configure the agent and put the correct brain in. So this, yeah, start of the battle generally, or end of the battle. So in here, configure agent, we enable the battle if we're not paused. We check if it's the player and it's not the demo mode or training mode, then we take the brain out. We set the brain to null because the player is providing the action, not the neural network. But otherwise we set the brain appropriately. So if we're in easy mode, we give the easy brain. If we're in hard mode, we give the hard brain, and then demo mode, we've got the normal brain, could be anything. In pause, we take the brain out just to make sure that nothing odd's going on. So yep, that's setting the brain as you'd like. And then these are all the start conditions starting that can't get called from the menu, whether you're starting a demo or the easy mode or the hard mode or whichever. So that's the scripts. And if we go back to that, we can look at doing the training. So for the training, we'll go back into Unity and let's check we've saved in here, and also check that we've saved the agent Dr. Arm in here. Make sure you've saved both of them where we made changes. And then we're going to go to this other scene. So we're still under Assets Dev Summit 2022 scenes. We were under the left one, but now we want to go into the training scene, which just says training. It's its name on the end. It's the right-hand one. And if I double click on that, if I hadn't saved, it would have complained and said, do you want to save? But I have already. So if I pan about a bit, give it a better angle, you'll see that it's very, very similar to what we had before, but there's 6 of them instead of 1 of them. This is so our training can go 6-fold, happen much faster if we have 6 of it happening at the same time. Could be more than 6. 6 seem to work well for us for computer capacity on my laptop here. Although the other thing we are doing is that we speed it up massively as well. So normally there's quite a bit of frame time where it's just sitting waiting for the next frame. We don't need that for training. We don't need that for to worry about that sort of thing. We want to go as fast as possible in the training. We want to get through hundreds of thousands of battles. So we speed that up. Now, when you do speed it up, you have to be very careful. We had a bug initially. The fireball was going off real time. So in training, when everything else sped up, everything else was on bullet time, racing around. The fireball would go slowly, and they didn't really care about the fireball because they were moving far too fast. So you've got to, when you're doing the training, if you want to speed up time, which is a good idea, just need to make sure it speeds up for everything, or it will learn the wrong thing. So yes, this is really 6 times. We've taken the light out. We only needed 1 light for the scene. There could only be 1 event system, so we've taken the event system out. We've taken the UI out because we don't need UI for training. So under here, the environment's now just the mesh. The agent setting, the ML core has the event system disabled, and there's no UI, but it's all pretty much the same. For the player, there's just a couple of very, very minor things. It's no longer set to is player in Dr. Arm because it's not being controlled by the player. And then in the ML player manager down here, we've got init on start because it does a bunch of extra initialization for the ML agent to make sure it's all set up. So yeah, we just got those couple of little things to set up training. And in battle environment controller, we've got ticked that it is in training mode. That's an important step as well. So yeah, just those couple of checkboxes just to make some slight differences in the scripts for training. And yep, we've got this. So we can now set off our training now that we've got our training scene. So for this, we need a command prompt. So we need to change directory to where you have unzipped the scene. For me, I've got it under Unity Projects, Dev Summit 2022 ML Workshop. I imagine that will be called something very similar at the end there. And then as part of those, the setup, pre-setup, you installed a Python environment, and that's ended up in Python envs ML agents R18env scripts. And if we activate that one, we can activate the Python environment, and then we can change to a subdirectory of this, assets, scripts, ML agents. Got all our ML agent stuff together in that folder to keep it tidy, where our scripts are for training, where our results are going to be. Saves us having long paths, keeps everything together. So if I change directory to that one, and then we have our command to set off, oh, there it is, set off the actual training. So the commands ml agents -learn, and then -- torch device is which GPU to use for your training. So CUDA :0 is just the default GPU. If you've only got one GPU like I have, yep, that's that one. And then we have the script that we're going to use for training, config bossbattle.yaml. I'll have a look at that once we've kicked it off. I'll come back to that. -- run ID. This run ID can be, you can call it anything you want. It's going to create a folder of that name. So we are going to want to keep track of that name. But yep, I've called it test new. You can call it whatever you like, but just keep track of it. Yeah, we'll create a folder. Then I've got -- force. You do not need that. That's force overwrite if it's happened before. Hopefully I don't need that either, but it's just to remind me. The other option that is probably even more useful is -- resume. So if you start your training and you either need to stop your computer or you think you've done enough training, you stop the training, it saves where it's up to, a checkpoint and the latest neural network. Then you can come back, decide that that's not enough training, I want to resume, you can resume. There's -- resume there. So if I hit return on that, it'll take a few seconds and then it should come up with a nice big Unity logo. Never quite sure how long. There it is. And a bunch of version information for your ML agents version and the like, PyTorch version. And then it says start training by pressing play button in the Unity editor. So that's exactly what we're going to do. So if I hit play on that, it will start our training and it'll go into game mode as play does in Unity, which will be a bit disorienting because we're strapped onto a random character who's moving very, very rapidly, faster than our frame rate. And so that's a bit horrible. So if I click on scene, then I get a much better view. I can see them all running around, a million miles an hour, looking silly, but hopefully learning how to attack each other, doing some fireballs, sometimes hitting each other. Now, there's not quite enough fireballs to kill the other one. They have to have at least one sword blow. And so it takes a while for them to learn to actually win. But if we go back to here, we start getting our results out here. So every 5,000 steps, it's going to tell us that we have a mean reward of -1. We're always losing. We have no winning. Get some slightly different things once we actually have some success. So yes, I said we're going to look at that script. So let's look at that script. I'll just show you where that script is and where we are. So as I said, we started off in that folder, the Dev Summit 22 ML Workshop folder, where the scene is, and then assets, scripts, ML agents. And then beneath that's this config. So these are the scripts we want to look at. And then also beneath this now is results, and then test new with the results in here. And it will save ONNX neural network and checkpoints in here as well. But yeah, these are the config here. And you may have noticed before when I was in Visual Studio that in fact, these are open. So I've got two very similar ones here. They both work. We're currently configured for Boss Battle. That was the one that was in the behavior script. We'd written Boss Battle, so we use this one. That's this Boss Battle here to give the brain Boss Battle for training. This was, use these parameters for training. And then we specified the script when we kicked the training off. The separation one, so this one's for giving both the characters the same brain. They'll have different instances of it, but it's the same brain. And these are the parameters to set it up. For this, they've actually got exactly the same parameters, but we'll give them separate brains. So we would have put in that behavior one, vampire and paladin for the knight and vampire for the enemy. But they've got exactly the same parameters as we had before, as this one has. Which one works better? Seems sometimes one works a bit better, sometimes the other works a bit better. Not really much difference. You'd think this one would be faster because it's training with both of them. But yeah, small changes can extend the amount of time or decrease the amount of time that training takes, and which one works better, it doesn't make much difference. So looking at this one, the training type is PPO, which is ML agent's algorithm. There's quite a number of different algorithms. If you go on their GitHub, you can learn about all the different ones. This one works, a number that work very well. This one works very well for our scenario. It's proximal policy optimization. Yes, there's just a question popped in. Yes, there will be a recording to watch this. I think hopefully it'll be up tomorrow. Yes, so yeah, there will be a recording put up after this that yes, you can follow at a slower pace. If you have any errors, you can pause it and keep going. So yep, that's a good point. Thank you. Someone's put in a very interesting error that I'm not sure where to start with that one. I both got that. String object has no attribute key. I'm not seeing that error, so I'll have to come back and think about that one later. I'll keep going for now. Yep, so yeah, that's the proximal policy optimization. Hyperparameters are just your normal machine learning type hyperparameters. So your batch size for your learning rate, your lambda and your number of epochs, just your standard machine learning things. This network settings sets up the actual size of the neural network that's using. There's two layers. So you have you start with your, oh, indeed, I've got a nice graphic of this, so I might as well use that. If we go to it here, the first layer is all our observations that I mentioned before, and we've got 3 stacked vectors of that. So the last 3 frames worth to make sure we find everything. That's all those bits of information going in. Then in this script, we're specifying 2 layers, 2 hidden layers, each with 128 units. The multi-layer perceptron, MLP, they're all fully connected layers, each to the next. And then the output, we've got the actions, which is the joystick movements and the 3 possible things you can do, the fire or the sword attack or the roll. So back onto this, yep. So from research, it looks like having more than 3 layers doesn't gain you much. But if you had something particularly complicated, you might want 3 layers and 256 hidden units maybe. This is plenty for us. There's 2 layers and 128 units for the amount of actions we can do and inputs. That's plenty. Down here is the checkpoints for during the training. How many times it just saves a checkpoint, not because you've stopped it, but just every now and then just to keep track. If your computer crashes, it's very pleasing that it has kept a checkpoint. It's keeping it every 100,000 battles at the moment. In this one, you can adjust that. We adjust that quite a bit as we try and work out which ones we want. And it will stop after 3 million battles if we haven't stopped it before then. The self-play is how often, these ones down here, how often, so only one of the characters is training at a time. If they've got the same brain, it's training that brain in one character, and then with this case, a team change 100,000, it changes to the other character and uses that brain in the other one for 100,000 battles. If the other one is still only training one at a time, but it's using a different brain for each one. And then swap steps for it'll accumulate 10,000 battles and then put in a new version of the brain to have another go with that one, all the results of that, and try and come up with something better. Cool, so that's that. And now if we look here, we're up to 75,000 battles, and we've got an ELO rating. That means somebody actually won. So ELO comes from sports, and is a rating, a way of trying to rate how good different people are or teams are. Complicated algorithm, but yeah, it's just a rating system basically. We've started them off with 1,200, but you only get a rating when someone actually manages to win. So somebody has managed to win a battle. Obviously not one only in the next lot though, because the next 5,000 battles, because we didn't get a rating there. But someone at least somehow accidentally won. So yes, we're still getting -1 here a lot. About 100,000 seems to be about when we kick in to start winning regularly. So if that's going to take all of it to, yeah, well, let's have a look at TensorBoard. That's our next thing. So this can tell us how we're learning. So this gives us the ELO number and other things. Let's set that off to see that. So this is this command shell's busy. I've kicked off another one here. Once again, starting in the workshop we were, and then going to the subdirectory assets, scripts, ML agents. So same directory again, so that we can get our results. This is the run ID I mentioned before. So results / whatever you called the run ID. TensorBoard logged results / run ID -- port 6006 -- reload multi-file true. And if we run that, then this will monitor and give us some ratings of how it's going. So yep, that's about to kick off. It should tell me it's running very shortly. There it is. Now it's running, and I can open that localhost 6006 in a browser. I'm just going to change over to the browser directly because I have a few pinned cards to make sure they're at the top. But yes, I could have just double-clicked on the localhost 6006 and it would have brought up. So the first couple of things to look at, the episode length. Initially, when no one's winning, the episode length is maximum. And so it's only really interesting. I'm going to need to refresh this. This is some old results. Yep, and I'll get off the ignore outliers to make the graphs a bit easier to see. Yeah, so until someone actually wins, the episode length's as long as possible, and then the average slowly comes down. Once they start winning regularly, it should come down a lot. But then at a certain point, it doesn't start dropping anymore. Same with the cumulative reward, starts off being -1 all the time because everyone's losing all the time. But once somebody starts winning, it starts going up, and it will often go up reasonably rapidly. And it will overshoot 0, but then it will start coming back down to 0 and go up and down above and below 0, because ultimately there's two characters that are very evenly matched, and on average they'll win 50% of the time, so the average reward will be 0. So those two are good to start with. The ELO lasts a bit longer for being useful, for seeing how good they are. Takes a while before it starts being useful on the other hand. But yeah, that will keep going up for a bit longer. Still slightly limited by the fact that they're only fighting exactly the same characters all the time, so finds it a little bit difficult to judge, but it will keep going up a bit longer and give you a bit better view of how well your training is going on, and you can decide if it's done enough that you think it's worth putting into your game and running and trying. But training takes sort of 6 to 8 hours, and we've got about 45 minutes left in our workshop, so that's not going to work. You'll have worked that out. So I am, in fact, going to stop the training. They're still doing cool things here, hopefully. It's just running around, lots nice and fast. occasionally winning now, and very soon we'll be winning a lot, I imagine, because where are we up to? Yeah, 100, or a bit past 100,000. Surprisingly, not winning a lot yet, but it won't be long. Yep. So they're about to start getting decent, but we can't wait for them to get really good. So I'm just going to stop it and go back to our original level and put the view back right there for that one. Now, if we go on agent settings and in this battle environment controller, we have the brains here. So these are the brains that we're trying to train. Once we've got them, we'll get these ONNXs to put in here, but we haven't got that much time, so we'll use some ones that we've prepared earlier. Here's one I prepared earlier, and we're looking for easier to be our easiest one. The one's from is about 100,000 steps just before it started winning lots, which makes it quite good. One for you to be pretty likely to beat. And then mediums a little bit further along, probably about 300,000 battles, 300,000 or 400,000 battles. It's quite difficult to beat. They rapidly become quite good. And then the hard brain, I think we left it for about 2.5 million battles, and we just used the last one. It's quite difficult to beat. And Sinus, thank you for. He's got an answer to one of the problems. That's good. Cool. So yeah, those brains in there, and then our scene should work if we save it again. Now that we've put the brains in. So yep, that will take too long. We'll put the brains in, and now the normal next thing that you would do is hit play here and try it out in Unity, because you want to check that it works before you start deploying to other devices. But hopefully, I'm pretty sure that this is going to work, so we can skip that step. Slightly different controllers that we had to work out for this as well, because the Android has on-screen controllers, but the Unity's not very good for the on-screen on my PC. I don't have that, so that needs an Xbox controller. So yeah, skip all that step, working that out. We'll go straight to deploying on Android. So to deploy on Android, we need to go to build settings. Now, what you want to do as fast as possible is double click on that Android, because the first time you do that to change over to Android being what you're going to run on, it takes a couple of minutes to install stuff. After that, I can switch between the two as fast as I like. It's all installed, but just the first time just takes that bit of time to install stuff. So now's a good time to start getting questions in, because there's a couple of things that take a little bit of time. And here, once Android's installed, I'm choosing development build. It seems to deploy faster for me. I'm not 100% sure it does. Unity's a bit variable with its deployment times. Yeah, it's not doing a whole bunch of optimization, so it should be faster. But it is leaving a lot of things in, debugging information in. So it's a much bigger thing to push. But I need development build for the next step when we're going to profile. So let's put it on development build now anyway. So after that, once you've got Android in, hit development build, and now we can go build and run. Now, for me, it's going to firstly say, so you have to save it, and it's going to complain that I've used that one before. Let's replace it, yes. So it saves the APK locally before it pushes to the Android. And for me, this will probably take about 1.5 minutes. For you, it probably take about 6 minutes. Well, I don't know how good your laptops are. It might take a very different amount of time, might be much faster, might be much slower, but hopefully faster. Yeah, the first compile takes that bunch longer. So now's a good time to look at questions whilst that's taking time for you guys. So, yep, looks like Syneth has got a good answer for Julian, so that's good. Yeah, don't know what that first error is. I've not seen that before. Oh, that solved it. Okay, excellent. That solved all that. Excellent. Thank you, Syneth, for solving the issues. Cool. What the metadata? Okay. Yeah, any other questions? Feel free to get them in, because yes, you've probably got a little bit of time where Unity's just going to be busy for a while. One little thing I've learned here when trying to deploy is don't have Teams running, because when I did a dry run of this with Teams, it suddenly blew out forever. So don't run Teams whilst trying to deploy things from Unity. Excellent. Yep, that's great. Yeah, any other questions at this point before we, whilst we're waiting for that? Okay, that's deployed for me. It's onto my phone there, so I'll be able to show you. It's also popped up this logcat, which can be very useful, but I don't want at the moment. But what I can do, more continuous versus discrete actions. I'm not sure what the question is. The continuous actions are the joystick, so sometimes you want continuous actions, like for the joystick, so whether you want to move a little bit or a lot, so that will be a continuous number. The discrete actions, like the other controls, the fireball or the attack with the sword or the roll, they're like single button actions. So it depends what output you want. So yeah, the continuous for things like joysticks. Yeah, those. Yep. So that's good. Did I path directly to my Android device? So I didn't. So here, that's a good point. On here, it's just going to default device. If you've only got one device attached, which most of the time you do, it's simple and it just works. If you have multiple Androids connected to your computer, then you are likely to need to choose which one or all of them. I've never tried doing all of them at once. But yeah, it chooses the device there. So it uses the ADB Android debug bridge thing that pretty much all Android connections use, and it detects the device. And if there's Unity detects the device if it finds one, then it will end up being the default device. And yeah, you don't need to put anything in for that path. It will just find it, and so just will run on that one. Cool. So build to device instead of build. Yeah, build and run is the one I want. So yeah, build will just make the APK and leave it on your device. Build and run pushes it to the device. So it is running on my device. I will just show that. I have a third one because both of these are busy now. And I have a utility called screen copy that you can find on the internet. It's very useful. And that is what is currently on my device. So if I choose demo, it'll start running. So if you've got it running on yours, as hopefully some have, or will very shortly, there's the fireballs going off and running around. Feel free to do a bit of playtesting at this point. The controls over here, that's the joystick over here on the left. So just your thumb pushes pushes that bit whichever way, and you'll move that way. And that's fireball, sword attack, and the roll or dodge going there. So those are the controls. If you want to have a quick play, check that it does work. You can have that. If there's any more questions, whilst some people have a wee play about with it. We'll have to actually hit each other at this point because they're out of fireballs, and I've lost. Disappointing. Yep. So that's what it's looking like on there. I'll close that. Anything else? No other questions in? No. Hopefully that's running well for you. I don't want to rush too much so that people can actually have a quick play before I move on to the profiling. But there we go. So yep, let's have a look at profiling. So this will be the page that we want to look at very shortly, but let's kick off that build. So I want to close the game on the Android machine, so that when we redeploy, it doesn't complain that it's already running or anything. So yeah, close it on the phone, and then we're going to build and run again. But this time, before we do that, we're going to auto connect Profiler. Hopefully it should deploy faster a second time. Yeah, it should only take the 90 seconds that it's taking me. Deep profiling support is useful when you need it, but it really slows it down. Both the deploying and then when you're running is really slow. So try and avoid it if you don't need it, but it's good if you do. And similarly, script debugging, if you need that, that's also quite useful. But I'm going to hit build and run on that. Once again, save over the top. Of the name of my APK. Yes, I want to replace it. That will deploy there again. And this time, because of the profiler, it's going to pop up the profiler in here. And it will look much like this. So because we're running at 30 frames per second, a large chunk of the frame is just waiting for the next frame. It's done all the work it needs to do. So if we zoom on the bit where it's actually doing something useful, then a big chunk at the end's rendering. As normal, there's always a big chunk of rendering. There's a big chunk of physics and animation update, but the behavior update's the bit that we're really interested in. So the collect sphere cast here is taking about half the time here. Is that ray perception, casting all those rays and getting them back, so that we've got the state of our environment. And then in the neural network execution, this is the actual neural network here. Boss battle hard, it's obviously playing the hard battle when recorded this. And the first bit's, yeah, putting all the bits into the neural network. Most of it's running the neural network, and then there's a very thin sliver getting the actions back out again, and that's the actual running the neural network. Now the profiler has come up for me. Fireballs to start with, and then I will just clear that so that we start just from ones that we care about. Only records about 300 frames by default. In the profiler for you to look back at. Now you notice, so the blue bit's scripts, and that's our behavior stuff's all within the scripts. And you notice there's a little jagged teeth-like thing, and that's not just about every 5 frames, it is every 5 frames, because we've said to run the neural network every 5th frame. So indeed, apparently I dropped out briefly. Hopefully everyone can hear me again. Am I back? Julian's not got the GUI controls. That's disappointing. So yeah, it doesn't show the GUI controls if it thinks there's an Xbox controller. If you've got an Xbox controller connecting by Bluetooth, you can control it by that. Indeed, then the controls will disappear. Yeah, it should show the GUI controls if it doesn't detect the Xbox controller. Yeah. Hopefully I'm back. Anyone can confirm that? Yes, so yeah, these jagged teeth are every 5th frame because we've asked it to go every 5th frame. So it runs a neural network and it takes a longer time, unsurprisingly. And actually, let's stop that because it's too hard to stay on a frame. So if I get that and zoom that down there, then we can zoom into here and we see exactly the thing we saw before. So here's our rendering, here's our physics, and here's our collecting the rays is a little bit less. In this particular case, it's taken slightly longer on the actual brain, but yeah, that's the running the brain with the putting the inputs in, running the neural network, and putting the output just like in that one. So yep, that's that there. And yes, every 5th frame. If I go to the other frames, there's much less happening because it doesn't need those steps. So it's much faster on the other frames. If you go frame to frame. Yep. Cool. So that's profiling it. And you can see the performance and then see whether it's doing too much and whether you need to do something about that. Cool. Right, so that's profiling, and then we'll just close that again on there as well. Yes, we can get to the summary, and we'll have time for plenty of questions at the end as well. So, yep, ML Agents gives great game AI and great game experience, a really good opponent to fight against, or whatever AI you want. It runs very well on ARM. So we just deployed it to Android. It's a workload that runs very well with us. We've shown how to include it into your project, how to include ML agents, how to train the agents up, how to run the project with ML agents in it, how to deploy it to Android, and how to profile it. So next steps, what could you then do with it? You could deploy to Windows on ARM, which is surprisingly easy. If I go back to Unity, there's this universal Windows platform. Unity have actually just announced that they're going to have a native Windows on ARM backend. Not quite sure when it's being released, when it's coming, but it is on its way. But for now, which will be faster, but for now the universal Windows platform runs very well. You'll need to choose the architecture of ARM 64-bit here, and then detect your Visual Studio version. Unless you're running your Unity on Windows on ARM, you'll want a remote device. Choose your build configuration that you want to run. And if it's a remote device, you need to put the IP address and username and password to be able to connect to that remote device. And then you can run on the Windows on ARM device you've got connected on your network, so that, you can check it out, and then it will just be build and run. You've got the same sort of options of profiler and development build and that sort of thing, build and run. Put the PDB files across so that you can debug it on the Windows on ARM device. All works very easily, deploys straight on there. And indeed, that's at Game Developers Conference when we were running Dr. ARM here. There it was on Windows on ARM. Other things you could do multiple characters, have a 3-on-1 battle. You have to work out training the characters together so that they work out how to work together. Also have cooperative characters so that you can have some people on your side as well as on the enemy side. With those, you need to start thinking about different rewards, having team rewards so that you can have self-sacrifice. You don't want scaredy cat enemies unwilling to take one for the team. You need to work out having some sort of team reward that makes it worthwhile for them to sacrifice themselves if that's necessary. You also have non-battle characters. Because not everything has to be a fight battle. You could have different ways of winning and losing, or different concepts of winning and losing. Some ways of coming up with different reward schemes. For reinforcement learning, it's quite flexible, but you really need to think about how those things are going to interact. Different sorts of characters, different sorts of scenarios that you want to have different rewards for, and train them up and train them together as well. Cool. So is there another question? Oh, excellent. Sign has got it working, was able to play. That's brilliant. And he's got a Bluetooth. Julian's got a Bluetooth controller. Excellent. So that's is playing with that. Brilliant. Okay, so at least a couple of people got it working really well. That's excellent. Any other questions about ML agents generally, or the ARM platform? Those. So we've got any questions to come in? No, if there's no more questions, then I guess we can finish a bit early. Yep, that all ran quite well. So yeah, thank you very much for attending. Yes, this is being recorded, so it will be up hopefully tomorrow sometime. Oh no, wait, there is a question. Yes, so ML agents, we had a very similar question about the lack of updates. I can assure you that it is being fully supported and there will be an update quite soon. Yes, we had some contact with the Unity guys because we noticed it hadn't been updated for quite a while. But yes, no, there's going to be, I think, quite a big update, hopefully soon. Yeah, it's meant to be before the end of the year anyway. But yeah, it is ongoing support. They do still have a team working on it. So yeah, there will be updates. There's some good updates that we've requested to them that they sounded optimistic might come through. We'll have to see whether they do come through, but particularly for things like staggering. So at the moment that's running the network every 5th frame, but the ability to stagger that so that if you have a bunch of ML agent characters, being able to stagger those characters so that they're not all on the same frame, so it doesn't end up with one really heavy frame, and be able to control how that works. And also batching characters together, which can be a more efficient way to run on processors. Some stuff around there that they seemed quite receptive to on both of those things. We had a few other requests as well that will help. And there's going to be a lot of over the next year. So I think less so in the update that's pending, but the next bit that they're working on, they're looking at making much more efficient. So it runs, you can have many more characters, and it'll be much more efficient to run. So that's something to look forward to. Yeah, we'll have to see quite what happens, but that's hopeful. Hopefully, some of those improvements come through. But yeah, there should hopefully be an update before the end of the year anyway. Cool. I'll answer that as answered, and as there's no other questions, I'll thank you all for attending, and we will put this up hopefully tomorrow. Cheers. Thank you.